Hello pianists, piano keyboard players and manufacturers. In this video I will show you some odd things about your piano keyboards and their keys, namely that they're not very well proportioned. The piano keyboard has quite an old design. In the very early times, about 1500 years ago, there were no short keys that we know them today as the black keys. Those were introduced around the mid-1400s, or about 600 years ago, one by one from earlier decades, starting most likely with the key for B-flat or bemolle, as it is known in Latin, which ultimately resulted in the symbol for a flatted big white key note. And it certainly looks like a rounded small Latin letter B.
Wow!
Where on the other hand, the so-called B natural has a square-shaped B, ultimately responsible for the natural accidental sign known in Latin as beccare.
Wow!
But this is another odd and terrible design for a music notation this time, which of itself is closely related to the piano keyboard. But I'm digressing, so let's stick to the topic of the piano keys. I am sure all of you have seen a typical piano keyboard, usually called a Halberstadt keyboard. The front areas or heads of the white keys have the same width size as it was in the very early hydraulius organ instrument from the 3rd century CE. But with the placement of the short black keys later in time, the tails of the big white keys obviously are not equal, or at least not consistent, as we will see, regardless of whether we have an Yamaha, Roland, Steinway or any other well-known or unknown brand of piano instrument. Once you see it, you cannot unsee it. In some keyboards, one of the keys, known as D or Re, has an excessively wider tail than the other white keys, as you can see. Later, we will see why that is. And this usually happens on digital piano keyboards. Just a few days ago, I found another variation or inconsistency for those white tail sizes. We can only assume at least the black keys would have equal widths. Here, now these tails seem to have the same size, where the inner two tails are narrower. How weird is that? But why such obvious problems happen all across the old and new piano keyboards? Let's take a closer look at the portion known as an octave cluster of the piano keys and the piano keyboard. Each of the big white keys has a head and a tail as mentioned. Then we have shorter black keys which are placed between some of the tails of the white keys. We can see how those tails have different widths here. What could be the reason for such a discrepancy, you might ask? Piano manufacturers won't tell you about it though, so let me do it. Usually they divide the keys of an octave cluster in two separate groups or sides, side 1 and side 2. Then at side 1 we've got 3 tails, their 3 heads and the 2 black keys in between. Respectively, at the other side too, we've got 4 tails and 4 heads and the remaining 3 blacks in between. We also have the gap where the divider line is, but we can disregard it because it's a common gap for both sides. Now bear with me as we have to do some 5th grade math. Therefore, we have this equation for our side 1. 3 tails plus 2 blacks equals 3 heads. Then for side 2, we will have 4 tails plus 3 blacks equals 4 heads. we're going to assume that the tails should be equal to the blacks on each side, as that is what we want to have really. We want to have equal widths in each side and ultimately equal widths between both sides. So let's also include the 4 gaps, one at each side of the 2 black keys, plus 2 more gaps between the heads of side 1. Then on the other side too, we can count 6 gaps plus the 3 gaps between the heads. Our equations get the following forms for side 1 and for side 2. A little tidying up to have the tails on one side of the equations, like this, side 1 and side 2. And now we solve for the t on both sides of the divider. So the equations finally look like this for tail 1 and for the tail on the side 2. To have some tangible values calculated, let's now give all the heads a nice rounded number of, let's say, 20 millimeters each, just for the sake of simplicity, with equal gaps of 1 millimeter each, and see what we'll get for the tails on each side of those equations. There we go, for tail of side 1 and then for tail of side 2. After solving, with or without a calculator, we finally can see the uncomfortable reality. The tails must have different widths on one side compared to the other side of the divider line. This is not good. We expected them to be equal, but they are not. And this is how piano manufacturers have done it ever since for the past 300, maybe even 400 years. Well, some try to transfer the widths from side 2 to side 1, but the tail for the key known as D or Re to have an excessively wider size, so there you have the answer.
It is what it is. It is what it is.
For example, here I shot this video of an old upright piano where you can clearly see how they made the outer keys of side 2 to have equal tails to those of side 1 at the expense of having to narrow the tails of the inside white keys of side 2 in order to preserve the heads to be equal at the front.
This was a triumph.
This is a proof that manufacturers have struggled to solve this evident problem. So, what is the solution to make all the tails, including blacks, equal, as the heads are equal across all the keys? The solution is really simple once you realize a very peculiar fact about the standard or Halberstadt piano keyboard. It has 2 symmetries because it has 2 rows of keys. When I was 14 years old, I saw up close a grand piano for the first time in my life. I got fascinated by its repeating patterns of white and black keys, but also, almost immediately, I realized that they were symmetric. One of these axes of symmetry divided the key known as D or Re right in the middle, and the other axis divided the key known as A flat or also as G sharp. But then, upon a closer inspection, I saw the discrepancies in the tails of the white keys from each symmetric group, and it haunted me for the next couple of years. I just couldn't get it. In order to equalize all the widths of all keys, we need to unify both symmetries by taking half of each symmetry and making an imaginary box or a rectangle out of those 2 halves. Then, with some precise inclusion of all the respective gaps and halves, using again a bit of 5th grade math equations, we can get the equal sizes. In order to do it though, we first have to assume all the tails are equal and also equal to the widths of the black keys. Then we find the exact width of a head for a white key, and that's it. if I could do it when I was about 15 or 16 years old, so can any of you do it now? But let me show you how it can be done with modern computer drawing visualization tools. Let's begin by drawing the width for the tail of the first key from side 1. We give it an easy value of 10 units, but it can be any, as we will see later. Then we add the gap next to that tail and let it have a size of 1 unit for the sake of simplicity. Then right next will be the width for the adjacent black key. Again, we will give it the same size as the tail, but it can be any size. These are our main driving parameters for the whole repeating pattern of piano keys. Let's now simply copy and paste those lines according to the repeating pattern of 12 keys and the gaps between them. We need another white and black tails, then 2 white tails followed by a black width. Next will be a white tail here, then a black one followed by a white and a black again. Finally ending with a white tail. We add a repeated white tail for the very first width using a dash line, and we are done with the tails and the blacks. Very important now is to mark the dotted line of symmetry for the D or Re key right to its tail's middle point. We draw the next symmetry line for the middle black width of side 2. Here I am showing that all widths drawn so far are of equal size. All gaps in between are also equal to 1 unit in this case. So let's continue with the heads. We do not know how wide they should be, but we want them to be equal in size as well, so we will have to temporarily give them equal length each. We need 7 of them. Well, the 8th one is the repeated head of the first key of side 1. This is how the pattern of keys repeats. The widths of the heads are equal now, so let's delete their actual dimensions. Very important step is to mark the middle point of the head for the D or Re key and its symmetry line endpoint. We mark similar point for the middle of the gap opposite to the black key in the middle from side 2. Let's draw a much obvious representation of the black keys so the pattern becomes more recognizable. There it is. Here is the best part of the solution, connecting the respective dots, pun intended. Here, the first pair is joined. Oh, but now the heads became excessively long. But please don't worry about it, as we have another pair of dots left to connect. Let's find the gap, there, and its weighting symmetry line endpoint. The box combining both halves of each side of keys can be imagined already. Also, see how the widths of the heads are now perfectly established and fixed. Let's give a normal length of the long white keys and start finishing the profiles of the same white keys. You can see the derived and driven value for the width of each head, and yes, they are equal. See for yourselves. But now let me show you the gently curve we need to connect the ends between tails and heads for the outer keys of each side. Here is the first one. Now we take the advantage of the symmetry to mirror it for the other key, repeating the same procedure for side 2. Done. We can do the same for the remaining lines of the heads, as we can take advantage of the symmetry lines. The main profiles of keys are ready to go, and here the piano key pattern emerges as completed. Sizes seem exact and as needed. We can play with the main 3 parameters, of course, changing the gap and the widths. One thing is certain, the respective lengths are equal to those chosen main values. And here is the repeating pattern representing a full set of keys you can find on pianos and synthesizers. When they are finally equal, the balance is so pleasant. Here is the initial set of values established for the demonstration. All tails and blacks set to 10 units each and the gaps to 1 unit each. You can see the driven or calculated size for the width of each head. And here is the final appearance for the keys, and I also made an overall concept of a whole digital piano keyboard and its enclosure. Surely those shapes you have not seen. More on their design in another video if you'd like me to make one, of course.